GATE 2016 Civil Engineering Set 2 Question 28. The angle of intersection of the curves x square equals 4y and y square equals 4x at point 0, 0 is. Four options have been given: A 0 degree, B 30 degree, C 45 degrees and D 90 degrees. The relevant NPTEL reference has been mentioned. If we are given two curves y equals fx and y equals gx, and let us assume these two curves intersect at 2 points A and B. So in order to find the angle between the two curves at say point B, we need to find the tangent slopes for the two curves at this point. So let us say the two tangents are somewhat like this. So the first tangent is a tangent to the f1 curve that has a slope of m1, and the second tangent is m2. So m1 will be nothing but df by dx at x equals b, and m2 would be the differentiation of the function g with respect to x at x equals b. This would result in the slopes of the tangent for the two functions at the point b. Next, we need to find the angle between these two tangents, or the same analogy holds for the angle between the two curves. The theta would be given as tan inverse of the difference of the two slopes divided by 1 plus product of the two slopes. So once we know the slopes, we can compute the angle between the two curves. In this case, we have been given two curves as y square equals 4x and x square equals 4y, and the angle needs to be computed at origin. So the first curve y square equals 4x would look like this, and the second curve would be oriented along the y-axis and would look like this. So we need to find the angle between the curves at the point origin, that is 0, 0. So assuming the tangent for y square equals 4x has a slope of m1, so that would be d of y1 divided by dx. Let us call this as y1. This would turn out to be d by dx of 2 root x, that is y1, which can be computed by taking the square root. So this would be 2 by 2 root x, which would turn out to be 1 by root x. So if we substitute x equals 0 for the origin point, we would get m1 as infinity. Similarly, doing this for the other curve, that is x square equals 4y at x equals 0, we would get d of y2 by dx. Let us call this as y2. So this would become d by dx of y2, that is x square by 4. This would turn out to be x by 2. The value would become 0 at origin. So now we know the two slopes. The angle between the two tangents can be found as tan inverse of m1 minus m2 by 1 plus m1 m2. Substituting the values, we would get tan inverse of infinity minus 0 by 1 plus infinity into 0. This would become tan inverse of infinity, that is pi by 2 or 90 degrees. This can also be seen that the tangent to the curve y square equals 4x is the y-axis, and the tangent to the curve x square equals 4y at origin is the x-axis, and the angle between these two tangents would be 90 degrees, which is obvious from the graph as well. So the angle of intersection of the curves x square equals 4y and y square equals 4x at the origin point was found out to be 90 degrees, that is option D. The relevant NPTEL reference has been mentioned.